Hi, this is Dr. Eddie Morgan at Clovis East High School, ready to help you with your homework tonight. We're looking in Math 1 at Worksheet 9.2b. Remember, every problem on this homework help mirrors a problem on your actual homework. So you're having a problem with one particular problem, look up, fast forward to that problem, and we should be able to help you. Let's get started. In our first two problems, we're finding the area of a triangle. If you remember, the formula for area of a triangle is the area equals 1/2 the base times the height. Now, some of you may recognize that the area of a rectangle is base times height. So is there connection? Well, let me show you. If I were to sketch this one we're doing right here, notice it has a 5 and it's 13 there. But notice that I could just as easily take this triangle, flip it over, and I would have a parallelogram. And the area of the parallelogram would be base times height. But notice then I have two triangles that are exactly the same, so the area of the triangle is half of a parallelogram. And that's where we get our formula from. And so we start here with area of a triangle is 1/2 base height. So I put in my two numbers. The base is 13. The height from the top of the point down to the base is 5. So we put those numbers in. Half of 13 times 5 is 32.5 inches, and that's our answer. Again, it is area, so it is inches squared. Second one, just put in the formula, 1/2 base times height. 1/2, the base is 9.3, the height is 10, so this is going to be 5 times 9.3, or 46.5 centimeters squared, and there's our answer. Problem 3 shows us a triangle where the base is actually split into two. We have 6 foot and 9 foot. You could actually find the area of two different triangles here if you wanted to, but in our case we just need the base, which is the full base, 6 plus 9 times 7. And so we'll put that in there. 1/2 base times height is 1/2 6 plus 9, which is 15 times 7. So we end up with 52.5, and this time feet squared. All right. Now on number 4, we need to notice that one thing here, we have a right triangle, and so I can use this, for example, here as my base, and then the perpendicular down here as the height. Actually, I could reverse them too. So the area, once we get our area, is 1/2. The two sides, in other words, the two sides next to the right angle here are your base and your height in a right triangle. So 1/2 7 times 10, and we end up with 35 square yards as the answer for that right triangle. Just remember, whenever you have a right triangle, you can use the two sides of the right triangle around that touch the right angle to be your base and your height. In problems 5 and 6, we have a situation where to find the height, if we use the base here, for example, in the first one as 11 inches, the perpendicular down, you notice, actually lies outside of the base. So there's our height, 6.5 inches. The only trick here is, remember, that it's still base times height. This means nothing in the formula. Okay? So if we go to our formula, it's 1/2 11 times 6.5. And that is 35.75 square inches. Likewise, in number 6, again, this doesn't mean anything. This is my base here, and this is my height. So it's 1/2 the base times the height, and the 2 doesn't figure into the area of the problem at all. So we get 1/2 10.5 times 8.4, which is 44.1 square meters, and that's our answer to number 6. Problem 7 says that we have a right isosceles triangle. So two things we have there. That means I have a right triangle, so there's a right angle, but it's isosceles. That means the two sides here are the same. All right? So I have a right triangle where the two legs are exactly the same. And then it tells me I have an area of 128 centimeters squared. So because it's a right isosceles triangle, the two sides, base and height, have the same length. So I'm going to let S be the side. So if this is S, then this is also S. And then if I substitute this into the area, remember the area of the triangle is 1/2 base times height. So the base and the height are both S, and the area is 128. I have this equation. 128 equals 1/2 S squared. Now if I want to simplify that, I'll undo the 1/2 by multiplying by 2. Got to do the other side as well. 1 half times 2 is 1. So I'm left with 1 s squared on that side. And we end up with s squared equals 256. That means s is the square root of 256, or 16 centimeters, and that's our answer. When it says of each leg, well, both legs are the same, so they're both 16 centimeters. Problem 8 says that the area of a triangle is 28 square inches. All right. The base and the corresponding height are in a ratio of 3 to 2. All right. So that means that the base to the height is the same as 3 to 2. They want us to find the length and the base of the according height. Well, first of all, let's use this equation here, this ratio, to solve for one of the equations. All right. So what I'm going to do is I'm going to solve for the base. Now notice it's the base divided by the height. So if I were to take this side and multiply by h, that would become 1. And so we multiply this side by h. So we end up with this equation. Base equals 3h over 2. Now we remember that the area for our triangle is 1/2 the base times the height. So I put the height, and then I put in this for my base. Okay? And now we're going to solve. Notice here's the area. The area is 27 equals 1/2 the base, which is 3h over 2, times the height. So let's simplify. So we get 27 equals 3h squared, 3/4 h squared. So to solve that, we'll undo the refraction by multiplying by the reciprocal. And so we solve that. Notice that 3 goes into 27 9 times. So we're going to end up with h squared equals 4/3 times 27, or 36. Now that means h must be 6 inches. So we know that the height of this triangle is 26. That's 1. And so now we plug it back into our first equation. Base is 3 heights times over 2. And so 3 times 6 over 2, 18 over 2. So our base is 9 inches. So the base is 9 inches and the height is 6 inches, and that is in a ratio of 3 to 2. Problem 9 asks us to find the area of the polygram. Now the strategy here is to divide it. We don't know yet. We're going to learn next lesson what the area of a trapezoid is. But for today, what we're going to have to do, since we don't know that formula of that, is divide it into two things that we know. And notice I can divide this into a parallelogram. And if I marked it off here, here's my parallelogram here. And a triangle. So here's my triangle here. So those would be the two things we can divide that into. And so as we go here, find the area of the parallelogram and the triangle, and then we'll add them together. And so our first step is the parallelogram. So the parallelogram is base times height. Notice that because the top of the parallelogram is 11, that means the bottom, the opposite sides are the same, so that's 11 inches. So my base is 11, the height is 12, and so we end up getting 11 times 12, or 132 inches. Okay? Now the next thing we can do is we can find the area of the triangle. Well, the triangle also, notice here, the height of the triangle would also be 12 inches, and the base is 13, but the area of a triangle is half of that. So 1/2 of 13 times 12, and that gives us 78 inches, and then we just add them both together to get the area of the polygon. So 132 plus 78 is 210 square inches. And that's the area of that trapezoid, and we found it by dividing it into a polygon, parallelogram, and a triangle. Question 10 says, does the altitude of a triangle have to lie inside the triangle? Explain. Well, if you just look up at problem 5 or 6, you'll see examples here where the altitude here, altitude here is outside the triangle, because it's an obtuse triangle there, and it lies outside. So that's obviously a case where this can be done. And so the altitudes of an obtuse triangle lie outside the triangle. The legs of a right triangle, by the way, are two altitudes of the triangle. So So that's an interesting statement as well. Problem 11 says that we have a triangle with an area of 18 square feet. Lists all the possible positive integers that could represent the base. Well, first of all, we know that the area of a triangle equals 1/2 base times height, so let's put in 18 for there. Now let's solve that, get rid of the half. So notice if I want to undo the 1/2, I multiply by 2, and 2 over here, and I end up with this equation here, that the base times the height has to equal 36. So what we're looking for is any two integers that the product is 36. So for example, I could have 1 and 36. Let me just put up here base and height. I could also have 2 and 18. 2 times 18 is 36. 3 goes into this as well. 3 goes into that 12 times. 4 goes into it 9. 4 times 9 is 36. 5 does not go into it, but 6 does. 6 times 6. So you see, those are the possible answers that we have. I think I printed this out as well here, as possible bases and integers, bases and heights for that triangle. The two have to just be multiplied to give you 36. All right, I hope this helped you with your homework tonight. Have a great evening.